Right, upper bounds, love upper bounds. So we've got a square which will look like this. There we go, that's a square, and so it has 4 sides, each of 8 centimetres, and we've got to find the area of the square. So obviously we've got to do 8 times 8, which is 16. However, they have not been, those sides have been measured to the nearest centimetre. They're not accurate. They're not exactly 8. 8's the nearest they are. So we've got to think about how high could each of those sides actually be. So I'll do very basic overview here. So oh, sorry, I'll call that 9. That's meant to be. Not very good. Right, so we've rounded to 8, but actually it could have been anywhere in this green area here. Anywhere in there would have rounded to 8, if that's supposed to be a ruler there. Which means that anywhere in between this number here, halfway between 7 and 8, that's, oh dear, let me just get my pen back, that's 7.5, and anywhere between 8 and 9, that's 8.5. That would round to there. I mean, obviously 8.5 itself would round to 9, but we're thinking about bounds, so it doesn't need to be exact. We're going to look at the maximum, even if it can only just go up to there. So we are going to use 8.5, even though if it were 8.5, it would round to 9. If that's confusing you, that's a little bit understandable, but it's just a bound. Okay, it doesn't mean it's actually going to be there. That's the top limit, even if it can't be it. So we're saying each of these sides is not actually 8. Let's just say the maximum, because we're after the maximum. What's the upper bound of the square? Each of these sides is 8.5, 8.5, 8.5. Doesn't look very good, never mind. And so we've got to multiply 8.5 by 8.5 to get our answer. 8.5 would have got you 1 mark, and when you multiply them together, you should find you get 72.25. So the most common mistake, which gives you a different answer, is to work out the area of the square and then round it up and down. So multiplying, so this is wrong, this green bit, 8 by 8, and saying, well, that's 64, isn't it? And then y is to the nearest centimetre, so that could be somewhere between 73.5 and 64.5, and going with 64.5. That's bad. Bad. Don't do that. You can see the massive difference it makes, though. And when you compare these two here, 72.5 and 64.5, and those bounds are genuinely really important when you start dealing with inaccuracies in real life, and architects and engineers will use bounds enormously. It's very important.